5 times 5 is?
25.
Yeah. Hey folks, welcome out there. It is Mathline time. It's Monday. Yes, it's a great day. And a few people out there are going to be out of school tomorrow. Some of you aren't though. But I'm Ernie Roberts, no matter how it turns out. And this is Mathline. We're so glad you've tuned in this afternoon. We want you to give us some calls, all right? 844-686-2378. No matter where you're from, whether East Tennessee, Middle Tennessee, Southeast Kentucky, Central Kentucky, Western Virginia, I can go on down the line. Hey, about Western North Carolina, all those great places. Give us a call, all right? And Upper East Tennessee also. We want to hear from you today. Give that number, 844-686-2378. What do? You give us some math problems that we can work out together live on the air. What better way to spend your afternoon right here waiting for dinner time? And, hey, have a little fun along with it. And start the fun off, let's take a look at our problem of the day. Problem of the day today goes back to the good old f of x, which is a function, by the way. So the function of x equaling to 2/3 x minus 5. We want to find the range of the function if the domain is 3, 6, negative 3, and 2. So again, we got this little crazy notation. It's called f of x equals 2/3 x minus 5. We're going to find the range of the function if the domain is 3, that's a number by the way, 6, another number, negative 3, another number, and finally 2. So let's take a look at it. Some of you are probably already on the move, getting it ready to rock and roll, to fix it up. Let's first of all understand what's going on here, because some of you are going like, Ernie, I'm not sure I quite understand what that notation up there means. So let's pick up this f of x business first. And f of x is just kind of a nice fancy way of saying, it's actually a very descriptive way, while it's fancy and stuff too. But it's actually a way of saying we're going to pick numbers in this domain, which by the way, that's what this report is about. This is all our x values. We're going to put each one of these in for x and then substitute. And we're going to see what comes out, which is basically a nice fancy name for y, f of x is, all right? So let's take a look at how this function works. It's really a nice notation. It really is when you get it in there and get it working. And this is one of the things we transition from the y equals 2/3 x minus 5. We really start transitioning this into 8th grade math. Also, the Algebra 1, Algebra 2, definitely a strong usage there. But you know what? Our calculator and all those technology things are still using y equals. So understand, they're interchangeable. They're working in the same way. That, by the way, whatever we get will be our range. So that's what we're trying to do. We're trying to find the numbers that 3, 6, negative 3, and 2 will take us to in the function as we see it. So let's make a table. I think it's an easy way to get started here. We're going to start with x, and I'm going to put f of x here, all right? And in that f of x part here, we're going to show the substitution. Now, I try to make the numbers kind of easy at first, the first 3, 6, and negative 3. Why do I say make them easy? Because they are divisible in with 2/3, all right? With the 3, it divides into 3 evenly. You got some nice things left. Now, this little 2 down here, might have to think just a little bit. Play a little fraction action, which is always fun in my opinion. And we don't want to forget how to do our fraction action. So let's see what we've got here. First of all, the numbers I've given you, 3, 6, negative 3, and we'll attach a little bit lower here for 2. And the idea is, oops, I just lost it there, that's all right. We'll start with 2/3, and remember what I said, we're going to replace the x with a 3, right there we go. And then we're going to subtract the 5. Now, some of you are okay with doing some mental math here. This is like having a 3/1. Can drop that little 1 underneath there, it helps a little bit easier. This is going to allow your 3's to go canceling, and you're going to end up with, looks like 2 minus 5, which by the way is equal to negative 3. So there's your first member of the range. Not because that was here, but because we just found it, all right? So there's your first member right there waiting for us to go with it, all right? Now, next one, we're going to do the same thing with 6. And I'm going to put a 1 under there right off the bat so we don't have problems. We never have problems. Now, you guys who are watching Mathline, you know what you're doing, right? So let's take a look at it here. The 3 divides into our 6 nicely. What is that going to give us? It's going to go 2 times, isn't it? And 2 times 2, that's going to be 4. 4 minus 5, I'm looking at negative 1, it looks like. All right? Again, check ourselves as we go here. A little cancellation here. It's going to be 3 dividing into 6 goes 2 times. By the way, we only have a 1 left down below. 2 times 2 gives us 4. Remember, we multiply, then we do the subtraction. Now, what about our negative 3? We put in 2/3, and we put in that negative 3, and then we subtract we subtract our 5. All right, we don't subtract minus 5. Please don't put that there. Now, let's play it out here, see what happens. I'm seeing 1s, but oh my goodness, we've got a negative 1 left here because that sign hangs on. So that's going to be a negative 2. How did I get that? 2 times negative 1 gives me that negative 2. Subtract your 5, and we're now at negative 7. So that one jumped around a little bit, didn't it? We were going up, and then all of a sudden we come back down. And last but not least, we're going to stick in that crazy looking 2. So we got 2/3 times 2/1, and we're going to subtract the 5. Now notice something, everybody, my friends out there. It is positive. There is no cancellation. We cannot cancel horizontally. So we are stuck with 2 times 2 giving us 4, and that's going to give us over 3, and we're going to subtract 5 from that. Now I'm going to be very honest with you. I think if we put a mixed number in there, it's a lot easier to think about, a lot easier to work with. So I'm going to let that be 1 1/3. How did I get that? Divide the 3 into 4. You got to go one time, put it the rest of it, remainder, 1/3, and then we'll subtract 5. My feeling is we're going to be back at, what do you think? It's a negative, that's right. Negative what? 3 2/3, which translates back to negative 11/3 for those of you who like the improper fraction vision. Because that's kind of what we started out with, wasn't it? We had a 4/3 there when we came through, but answer basically, here we go. That would be one of our range. There's the negative 7. There's the negative 1. There is the negative 3. Now let's do a quick check on the calculator. And going to there, we're going to go with y equals. I love graphing because that's what this is. It's just naming ordered pairs. So 2 divided by 3, pop in your x. And why not? We're supposed to subtract 5. Make sure you put a subtract. Don't put a negative on that. It'll give you a syntax error, and then you're going to go, what did I do wrong? It's okay. It's all right. So this is telling me we're going to divide 2/3, then we're going to multiply by x and subtract 5, which is exactly what we've been doing, right? So let's graph that. It's a pretty little blue line. It should be on your screen. And we're going to put some of these numbers in. We're going to play trace. Takes us right to 0. Unfortunately, I didn't give you 0, did I? So let's go to the 3 first of all. Let's see where it lands. 3, we press enter, see where it goes. Gets us negative 3. That goes back to our answer. That's good news. So we checked very well there. Again, the y values are the range. That's what we are looking for. So we're going to put them all together in just a second once we check them through on the calculator. How about it? Let's put in 6. Enter. We're at negative 1. Exactly where we said it was supposed to be. Pick up your negative. Now remember I said it's going to be different. Put negative 3 right in there. We're going to trace. Hit enter. And my goodness, we're at negative 7. Life is good. 3 for 3. Now you say, Ernie, what are we going to do on this next one? We're going to do just what it says. We're going to put in 2. And it's going to probably give us a decimal because that's what the calculator does so well. That is a negative 3 2/3, folks. And that is what we said it was supposed to be. Let's go back to our front page here. And our range again is going to be, put it right up here, is going to be a negative 3, negative 1, negative 7, and our last member of the range was negative 3 2/3. So there you have it. That's your range for the domain. And again, it's so nice because remember, this whole thing is a linear graph. It's a linear function. You can check with your graphing calculator, or you can just kind of check your points and see if they plot on that line if you go and make it yourself on nice little gridded paper. And that, folks, problem of the day for today, all right? Now, what we need to get you guys doing is give us some calls. Like I said, some of you are out for school tomorrow, some of you are hoping, some of you are waiting. But right now, give us a call, 844-686-2378, because some of you have still some assignments to do. Maybe they're going in online, maybe they're going in to when you get right back to school, and some of them are still going to be due tomorrow. So give us some calls, all right? 844-686-2378. We would love to help you out this afternoon. It's free, doesn't cost you anything. There will be someone answering the phone out here. You get to talk to me live on here, and we'll work it out together. All for no cost. What can you say more than that? And a great way to entertain yourself this afternoon. All you got to do, pick up that phone and let's get calling. 844-686-2378. Now, while we're waiting here a little bit, we do have a new feature on Mathline that's going on, and Facebook's already kind of taken off on it a little bit here. And we're going to do it here also. We don't want to be leaving out anybody that's not on Facebook. You know, we want to make sure everybody has a chance to play this game. We're looking at a problem of the week, and that's what we've got here. This is our problem of the week. What we're going to do, we're just going to give you a little bit of tidbit of information on each day, and we will gradually be able to pick it up and hopefully solve it by Thursday and have a true answer. Now, some people on Facebook have already gotten really crazy at it and going at it, and they're telling me all sorts of interesting things. You may want to check that, our Mathline Online Facebook page, to see what are they talking about. What are they talking about here with all this problem of the week, as we call it, all right? We just did the problem of the day, but now problem of the week, we've got a different story. Let's take a look at it here. Which is the better buy? A large pizza with an 18-inch diameter. I don't know if that's just a large to me. It almost sounds like it should be extra large because that's a good-sized pizza, all right? And it's making me hungry here around the dinner hour. For $15, all right? Pretty good deal, I think. Or the medium pizza with a 14-inch diameter for $9. Now keep in mind, that's diameter. That's not radius. That's the first thing we want to make sure everyone is cued in. You've got to take it, and by the way, the question asks, which one is the better buy? I guess you would want to say, yeah, which is the better buy? But then how much less is the better rate per square inch? All of a sudden, I've gotten kind of mathy about it, haven't I? Some of you are going to say, I'm going to flip a coin. Or I think I like the $15 one. Those are always larger. You know, those are always better deals. Well, you know, check it out. Do the math. Work the math through there. My first clue is you need to find the area of a circle. And you need to do it twice. Now, you say, Ernie, what do you mean? Say, we got two circles here because that's the way we're selling this with diameter. All right, that gives you a hint. We're talking about circles. And if we're looking at area of a circle, we are going to need to involve the radius. So we got this area, we're going to use it twice. We're going to pick up radius or radii for the fact that you're going to have two of them. But let's look for the radius of the large as well as the radius for the medium. All right, and here we go, little equals. We can figure this one out. This one's not hard. 18 inches is your large diameter. Remember, radius is half. Why is this important? Again, you're going to need to do this in order to get those square inches. That's area. That's area. So you've got to use, by the way, use this twice for two different things. First of all, for the 9, and that's inches. And then also for the medium, which is going to rank in at 7. And then you're going to get to check them out and check out their cost. It may surprise you. It may be just what you think. But when you get through, you want to be able to also say, how much was it the rate per square inch? That's your big part of the problem to figure out. Yeah, it's easy to flip a coin and say A or B, right? But when we have to get down to the showing why it works, that's the thing I want you to get after that on this one, okay? So take into it. You've got through Thursday. I'll give you a hint every day on the show here and let y'all work it out a little bit there as we go along. But the first thing you got to do is find out what's the area of those pizzas. Then you can start talking about what's the rate per square inch, all right? So go for that. That's your hint for today. That's your hint for today. The next thing we want you to do, folks, is get on those phones. Let's get some phone calls going here from all over Tennessee, all over Kentucky, West Virginia, Western Virginia, and Western North Carolina. We want to hear from you this afternoon. Get some calls going here. It's a lot more fun. The show rocks a lot better when you guys give us a call and let us talk with you and let us work out some problems together. So to get us warmed up, we always have a few things here to prompt you. We're going to prompt you a little bit more here, all right? Let's take a look at a simple, I think it's fairly simple, but we'll check it out, equation. Let's take a look at this one. So solve the equation for P below. So P is our variable. We are looking for that. And another thing, it didn't say, but we will do it. You know, I like us to do it. We always like to check our work to make sure it is good here on Mathline. Because, you know, it's easy to mess up, especially when we see these -2 type things outside the parentheses. So watch your signs, watch your parentheses, because you're going to be distributing. We're going to be distributing because I'm going along with it too. I'm taking the ride with you. I put those arrows because sometimes we go to 4 times 2p and forget about that -5 out there. Don't forget about the -5. That will be bad news if you do that. Over here, we're going to distribute with the -p or the -p, however you want to look at it. We're going to run it through that parenthesis, and we're going to watch a lot of sign changing as we work through the p and also through the 4. Don't forget, and that 4 has a minus in front, which makes things even a little more interesting. So here's what I want you to notice too. There's a lot of things I want you to notice in this problem. Where do we start? Some of you already jumped in, I bet, at home and said, oh, 20 minus 2. Life is good. That's just a lot easier to look at. We can't do that. All right? It's against the rules. Got to go to the parentheses first. Yeah, the order of operations allows us to go to parentheses and also works very well in the situation. If this had a parenthesis around it, we'd go there. But we do not have a parenthesis around 20 and minus 2. So we're going to have to worry about the 20 after we deal with the minus 2. So let's take it one step at a time. One step at a time. That's all we can do, right? So let's work out this part right here. If we can get rid of the parentheses, we're halfway home, I think. So we distribute through. I'm seeing 8p, because it's 4 times p, not 4 plus p, but 4 times p, minus the 20. Yes, 4 times a minus 5. That's going to give us a minus 20 there. Keep the sign. Do not change it. Over here we have big old 20. Like I said, don't put a minus 2 with it yet. We'll get there. Instead, put the minus 2 with this p coming up. And remember I said, it's like taking a negative times a negative, which is going to go positive. Your signs are going to change. And already we have some interesting connections here. I see a 20 here and a 20 there. Interestingly enough, some of you are going, oh, they cancel. Don't go there yet. Let's find out later. Here we've got, looks like what, 8 and a negative p. And again, don't decide you want to subtract them now. One's on the right-hand side, one's on the left-hand side. We can't just join them together. There's an equal that's keeping us from it. Sounds like a little river. Some of our teachers use that approach. I love it. That you kind of draw a little line here and say that unless you cross the river, when you cross the river, then you're changing signs, all right? Now you can divide, multiply like you have it there. We'll talk about that in a little bit. But when it comes to adding and subtracting, you cannot go across that river without changing the signs. So I do want to get this 8p and this minus 2p together. However, how do we do that? You know what? I think we need to go for like terms first. Let's make this thing look a little easier. How about it? Let's add 20 and 8 on the right-hand side. I'll run my little equals right down. That's not a not equals. That's just a river. Don't cross it, okay? Unless you're changing signs. Now, we've got 20 and 8, which gives us 28 minus 2p. We have also 8p minus 20. This looks more like the kind of equations you're used to seeing after a certain point. This whole idea. We clean things up every step, make it look a little easier, We're simplifying, and then we're finally down to a point where we can just say what that p value is here. So let's do something about it. Let's add the 2p. Why? Because it says subtract. So the way we disconnect to subtract, we have to add. And if we do it to the, you got it, to the right side, we got to do it to the left side. We call that the addition property of equality, and it's a good deal because over here we have now 10p minus 20. Over here, my goodness, the 2p's go, we got 28. All of a sudden this is looking easier and easier each step. Let's take, and by the way, notice what we did. We changed signs, so we had to do it to the other side, so we got to be careful. Notice it's not 6p, is it? No. It's 10p. So let's keep that thought in mind. Now it's time to add the 20. Add 20 to both sides. And I'm seeing 10p hanging out by itself. Over here, we're equal to 48. You say, Ernie, that doesn't sound like it's going to come out even. Well, it is going to be all right. It's going to be all right because what was going to happen is we're still going to be able to make a decimal format. We're going to divide by 10, and that's easy. When we divide by 10, by the way, we're going to do that to both sides, divide by 10. It's just like shifting a decimal point to the left in the 48, one place, which is going to give us 4 8/10, or 4.8 as we love to call it. And those of you who are really into fractions, which I don't know why you'd want to be on this one to put 4 into this, especially when we're going back and check it, but you'd be happy with that. It comes out even, so it would have been what, 4 4/5. So if you went that route, that's fine also. Again, we want to check. So let me bring it back down here and let's play through this thing. And while I'm playing through this thing, folks, give us a call, all right? We're almost through the show, and we haven't heard from many, if anybody, yet. So we would love to hear from you guys today, so please do that. 20 minus 2 times, we'll put it in here. We got what? P minus 4. That's not going to be the happiest moment, but we're going to take care of it. And, oh goodness, we can handle that. Everybody says we can handle that. Yeah, Ernie, we can handle that. We're going to do fine. So here we go. Let's put in our 4 8/10 right there and right here. And let's go ahead and play out of the parenthesis. We're going to double we're going to say 2 times 4 8/10. And my friends, that's like saying 48 or $4.80. What's double that? You know, you guys do well with money because you think a lot about it. You can put that, you can do so many things with numbers that you don't do otherwise. But that's 960, okay? Or 9 6/10, we'll say. And subtract 5 from that, it looks to me like, what are we back to? Well, how about it? Let's just take one step at a time, you say, right? How about it? 9 6/10 minus your 5, keep the 4, keep the 20, keep the 2, but now let's figure out what's going on over there. That's really pretty easy. That's going to be 8/10. Everybody good? So far, so good. All right, now, what I'm seeing is 4 times, do subtraction here. We've got 4 6/10 equaling to 20 minus, we can get that one real easy. Go ahead and do the multiplication. Remember, you do that first. Yeah, 20 minus 2 is really tempting, but don't play that game. Go here, 1 6/10. Life is good. Life's going to be better when we get to the end of this one, right? And let's see where it goes. I think, yes, we do. We have 18 4/10 over here. Those of you who don't believe me, let's go back here to the calculator. Let me get rid of this one. Okay, let's try it. 4 6/10. Drum roll time. Not the longest drum roll, is it there? Let's see. I got 18.4 on that side. 18 4/10. That's our check, all right? That was not quite such a mental check, but there we go. We're back at 18 4/10 on both sides. Check it out, and checks off there. So again, even if the problem has a little bit of complexity, go back and check it, all right? Just take that time and make sure you get all the nice intricacies, because it's easy to kind of put the wrong thing on the wrong side on a problem like this. We don't want you to do that. Now, what we do want you to do is give us calls, okay? 844-686-2378. We've got just a few more minutes to go here. Don't want to lose out on it, but I will tell you this. We will pitch a little bit to our YouTube here in just a second, if we can. We've got you that you can always go and look at Problem of the Day and our specialized segments on YouTube. There we go. And you got to subscribe to that. It's really easy to subscribe to www.youtube.com/Mathline. I'd say the majority of the folks who are watching Mathline have already subscribed to that YouTube business. But don't forget, go ahead and go put Mathline in on there also, all right? Of course, right now you got the call going on, 844-686-2378. We'd love to hear from you there. Let's talk a minute on Facebook also. Facebook is another one of our great outreach moments there. And we like it when you love us. We love it when you like us. We love it, period, when you get there with us, and share us, if you will. So many times I see some of our faithful readers and viewers have come through and shared that problem of the day with other folks in their whole grand scheme of their community on Facebook. And that's wonderful to see. Hopefully we pick up a few more. I see new names from time to time on our problems of the day. We want to see more of you all feeding your answers into problem of the day also. So there's your best way to get it done and to take care of it. Now, I want to go back one more quick moment here, since I think I haven't gotten any calls yet, and we're probably not going to get any before the next 2 minutes. If we do, it's still hard to get you through. But let's take a look at that f of x problem just a minute, one more time here. And we gave you, I said you could do it without having to have a graphing calculator. I want everybody to understand that that's so true. So what do we have? 2/3 x minus 5. And we got a lot of ordered pairs, all right? Our first ordered pair, I have to go back and remember things. Let's see, where did it go? Where did it go? There it is. Hang on, folks, we got it under control here. Whip it across here. With 3, when we put 3 in for x, we got the ordered pair. We got a -3 with that, okay? So we got -3. There's one of our, that's, by the way, part of the domain. The 3 is part of the domain. -3, in this case, was part of the new range. Let's go with our next one. We put in a 6, and we also popped up a -1 for that one. When we put in the -3, I always like to throw in a negative number for good measure, all right? It just is a nice thing to have. We ended up with a -7. And last but not least, we had that crazy one that said what? 2, and we ended up with a -2 and 2/3. So what we want to do real quickly is graph these points. And you know, all it takes is 2 points to make a line. But when you got 4 of them, if they will all line up, you know you've done a good job with it, all right? You know you got the good values going pretty much. So let's take a look at it. To the right 3 and down 3. There's your first point. How about it? We're going to go to the right 6 and down 1. That's the negative 1. Remember, that's what we do when we go x and y first. Ordered pairs. That's why they call them ordered pairs. A negative 3, ooh, way back over here. And down 7. 2, 3, we're almost off the page there. But notice these things pretty much look like they're going to line up. And then we got that little crazy one, that little 2 and negative, what is that one? Negative 2? I believe it was negative 3 2/3. Am I right on that? Yes, it was negative 3 2/3. So good, we'll fix that. And that's going to be negative 2 and right about there. And that's the one I would worry the most about. Is it going to line up? Because it's hard to estimate where 2/3 is. But you know, it works pretty well. And when we take our little straight edge moment, there it is, come on back, and we connect, we got those things lining up beautifully. And so you can create your own line. You create your own linear graph there. And notice one good thing that we didn't use, if we put a 0 there, we had -5. So we know it all works. That's one way. And another one, you know, some of you are saying, Ernie, could we put -5 and gone up 2 over 3, up 2 over 3? Yes, we could. So many ways to work that problem, but there's you go, all right? And folks, thanks for tuning in today. Like us at Facebook again, and you know what? We will be back again tomorrow. See you then.